question. It's pretty challenging. It is pretty challenging. And if you get on the right thing right away, it's not so challenging. Now, you can do it in different ways. Mr. Autry and Mrs. Fallen, we did it in different ways, but myself and Mrs. Martindale, we did it in kind of the same way, except I forgot that in triangle PQZ and triangle RQP, they've given to us that they're similar. So I don't need to do all this work here. It's given way back in the second question in this section. They said that triangle PQZ is similar to triangle RQP. So I don't need to do all that work up there. It's given. Well, but if that's true, then PZ over RPR equals PQ over RQ. And that means that PR over, I could put PR over RQ equals PZ over PQ. Now, why I did that is because we were given this, that PR equals PW times QR and QE. But we're supposed to prove that something equals PW. So all we do here is divide by QR and multiply by QE, and we get the beginnings of our thing of trying to prove this. See, we've got the QE there, we've got the PW there, it's just PR and QR. But hang on a sec, PR and QR are really equal to PZ and PQ. So you put that back in there, PZ and PQ. Now we almost have it. We almost have it. All we have to do is, why is PQ, could it be equal to the square root of QRQZ? And it can be, because PQ squared before is equal to RQ times QZ. And we just take the square root and we get PQ is, if we take the square root of both sides, is equal to this thing. So Mrs. Martindale and me did exactly the same thing, except she was smarter, because they said, if this is true, which means they've kind of given it. And I didn't. I did a bunch of work I didn't need to do. But there's the question. I think it's a nice way to do it. If you look in the slide presentation, you'll see other ways to do this question. But it was pretty challenging. But that's the last video. All done.